The main topic is acid, base and salt, and the subtopic is about the preparation of the salt, how salt can be prepared. First, the definition of a salt, how we define the term salt. The salt means when hydrogen of the acid is replaced by the metal, we call that as a salt. So whenever we have, like in acid we have hydrogen, but if that hydrogen is replaced by the metal, we call that as a salt. Example, HCl. HCl is known as hydrochloric acid. So HCl is refers to or known as hydrochloric acid, but when this hydrogen is replaced by any metal, like example, in place of this hydrogen, if we write any metal, sodium, calcium, magnesium, any metal we write, so that hydrogen is replaced by the metal. So instead of hydrogen, if the metal is present, what we call that? We call that as a salt. So basically, this is sodium chloride salt. Another example, if we say HNO3, HNO3, that is known as the nitric acid. So HNO3 is nitric acid, but if this hydrogen is replaced by the metal, this is nitric acid, but instead of this hydrogen we write any metal, example calcium, which is group 2. So calcium valency will be +2 and nitrate is -1. So formula for calcium nitrate will be CaNO3 in a bracket 2. So as you can see, this instead of hydrogen we have a metal. So instead of hydrogen, if we have a metal, what we call, basically this is calcium nitrate salt. So whenever the hydrogen of the acid is replaced by the metal, the substance which is formed is refers to salt. And the salt, as we already discussed in the topic 2, which is about experimental techniques, the salt can be soluble. All the salts are solid at room temperature. But what will happen when we add water? Then there are two possibilities. Some of the salts might dissolve, we call that as a soluble salts, and some of the salts does not dissolve, and we call them as insoluble salt. So a salt, when hydrogen of the acid is replaced by the metal, that is called salt. But what happens then, there are two possibilities for a salt. So all the salts are solid at room temperature, but some of the salt dissolve in water. Like example, you have a container which is filled with water. If we add this solid to water, sometime the salt dissolve. When the salt dissolve, it disappear, we don't see anything. So what we call this salt, we call that as a soluble salt. But sometime what happen, when we add the salt, that does not dissolve. So if the salt does not dissolve, what we call this, we call that as insoluble salt. And there is a table which you have to learn about the soluble and insoluble salts. So remember, all the salts are solid, but when they are added to water, some dissolve, some does not dissolve. So what are the soluble salts which can dissolve in water, and what are insoluble salts which does not dissolve in water? So the table, all nitrates are soluble. So any salt which is having NO3, they are soluble. Most chlorides are also soluble except three. The three chlorides which are not soluble is silver, mercury, and lead. These are the chlorides which are insoluble, does not dissolve. Most sulfates, most of the salts which are having SO4 are also soluble except three which does not dissolve in water: calcium sulfate, barium sulfate, and lead sulfate. These are the three salts which does not dissolve. And most carbonates are insoluble. Most of the carbonate salts which are having CO3, are insoluble, does not dissolve, except again three. What are the three exceptions? Sodium, potassium, and ammonium. So these are the three salts which, three carbonate salts which dissolve in water. So most of the salts, all nitrates are soluble, means any salt which is having NO3 at the last, the salt which is having NO3 at the last, even any metal is connected, but if it is having NO3, it will always be soluble. Most chloride, most of the salt which are having chloride are soluble except three. Silver chloride does not dissolve, mercury chloride, and lead chloride. These three chloride does not dissolve. Most sulfates, most of the salts which are having SO4 are also soluble except three: calcium sulfate, barium sulfate, and lead sulfate. These are the three sulfates which are insoluble, and most of the carbonates are soluble. Like most of the carbonate are insoluble. Carbonate means they have CO3, except three: sodium carbonate, potassium carbonate, and ammonium carbonate. Ammonium carbonate is NH4 in a bracket to CO3. So this table is very important. You have to learn this table, the soluble and insoluble salts. So it's totally based on memorization. You have to learn this table to identify, because there is a different way to prepare types of the salt. If you want to prepare soluble salt, we use different technique. If you want to prepare insoluble salt, we use a different technique. So example, if you want to prepare soluble salts, the methods which we can use, all the characteristic of acids, or all the reactions of acid can be used to prepare soluble salts. And what were the reactions of acid? The first, when acid plus metal, that gives, so when acid is mixed with metal, this will give salt and hydrogen. The second is when acid is mixed with metal oxide, which is also known as a base. or insoluble base, it will give salt and water. The third one, when acid is mixed with metal hydroxide, so acid plus metal hydroxide, this will result in a formation of salt plus water. And the last one, when acid is reacting with metal carbonate, so acid plus metal carbonate, this will result in a formation of salt, water and carbon dioxide. So these are the four reactions whenever you want to prepare a soluble salt. What is the meaning? Because what happens when acid is reacting with a metal, this directly produces a salt, but that salt will be dissolved like a solution. Same thing, when acid react with metal oxide, this will produce a salt, but that salt will be dissolved. Like it will not exactly form salt, it will be a salt solution, dissolved salt. And from the solution, we can obtain the salt by either crystallization or evaporation. So if you want to prepare a salt, a soluble salt, so there are four techniques or there are four ways to prepare a soluble salt. Number one, we can react acid with metal. Number two, we can react acid with metal oxide. Number three, we can react with acid with metal hydroxide. And number four, we can add acid with metal carbonate. So in exam, they ask to write the whole experiment, like how you will prepare a salt. So this is very important. Even in paper 6, you will find a question, a 6-mark question is there, that experiment to write an experiment to prepare a salt. So this topic is very important. So how to prepare a soluble salt or salts which are dissolved in water, how we can prepare them. So first one, preparing a soluble salt, the first technique, when acid is reacting with metal. When acid react with metal, as a result, what it produces salt, but that salt will be solution plus water. So that salt will be a salt plus hydrogen, not water, because it is a metal. And one more thing you have to remember, that not all of the metal react with acid. There is a reactivity series. What is the reactivity series here? We have potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, mercury, silver, gold and platinum. So till this point they can react, because in lab we are using a dilute acid, so they can react with dilute and concentrated acid both. Like if acid contain more water or less water, they can react with both of them. But metals below lead, they can react with concentrated acids only. So concentrated acid, we don't use concentrated acids in the lab. That's why we don't observe their formation of the salt, very common. So whenever dilute acid is there, it can react with potassium, sodium, calcium, magnesium, aluminum, zinc, iron and lead. And as a result, what it will do, it will produce salt and hydrogen. But that salt will be a dissolved salt. Basically, it will be a solution. Like salt will be dissolved in water, and later we can take it out by using either evaporation or crystallization. So example, If you want to write an experiment to prepare a salt when acid is reacting with metal, so example, we took hydrochloric acid and we mix hydrochloric acid with sodium. So when hydrochloric acid is mixed with sodium, so as a result, what happens, because when acid is reacting with the metal will take position of hydrogen. This sodium will take position of hydrogen. So as a result, the product will be sodium chloride, because hydrochloric acid gives chloride salt plus hydrogen will be there. So this will be the product, but experimentally, like experimental procedure, how we can work out in terms of experiment. So what we will do, we'll take a container and we fill this container with dilute acid, because in the lab we don't use concentrated acid as they're highly corrosive, so we use hydrochloric acid. So we use hydrochloric acid here, and then what will be the state? Acids are aqueous. Aqueous means acids are always like in dissolve in water or solution. What is the sodium metal? It will be solid. So we'll take a piece of sodium. So this is a sodium metal. So when we add this sodium, a piece of sodium to hydrochloric acid, the reaction will occur, and as a result what it will form, because sodium react with hydrochloric acid, so it forms sodium chloride. So when it forms sodium chloride, this whole solution contains sodium chloride. And what happened to the size of this solid? Because the solid is reacting, the sodium is reacting, so we'll observe the size of the solid will decrease. And because hydrogen gas is there, so whenever hydrogen gas is there, so we will observe or we'll see bubbles. So what are the steps? Because in exam it is important that you write the steps how you prepare this salt. So what are the steps to obtain or form a salt, a soluble salt from reaction between acid and metal? Number one, we will add excess of metal. What is the meaning of excess of metal? The term excess means until no more reaction occur, like all of the acid is used up and you are left with metal only. So if you use excess of metal, like you use greater quantity or greater amount of the metal, then as a result what happens, as at the end of the experiment the metal will be left as the acid is completely used up. Because whenever two reactants are there, one of the reactants should be in excess, like more than enough, so that the reaction completed. So first what we did, we add excess of the metal, like more than enough metal, too much metal, so that all of the acid used up. The second thing what we do, because when we use excess of the metal, there will be unreacted metal. So we will remove the unreacted metal by filtration. So the metal which does not react, the reaction completed, and the metal which does not react, example, this is an unreacted metal. In this case, it is unreacted sodium. So if we have unreacted metal which does not react, so how we can remove it? We will remove the unreacted metal by filtration. So once we remove it by filtration, this metal will be removed, and what we are left with, we are left with only a salt solution. So from salt solution, how we can obtain a salt from the salt solution? So there are two ways. There are two techniques to obtain a salt from salt solution. Either You can evaporate, like you have a salt solution, you supply heat energy, you evaporate and the salt will left behind, or we can use crystallization. So in exam, because it's of normally 4 to 6 mark questions, so it's better you write the points of the crystallization. What we do in crystallization, in evaporation, we remove all of the liquid. But in crystallization, what we do, we heat and concentrate the solution, then we cool down the solution, and when the crystals form, we will again filter them. So remove unreacted metal by filtration, then use crystallization to obtain salt from solution. And better mention the points of the crystallization. What are the points in crystallization? We will heat and concentrate the solution. Heat and concentrate the solution means we supply heat energy and remove the liquid out, water out, so that we'll have greater amount of like in a small quantity we have greater amount of salt. So heat can concentrate the solution, we will cool down the solution, and heat and concentrate the solution till the point of crystallization. It means until the crystals start to form. And then we will cool down the solution. What is the reason why we cool down the solution? Because at a lower temperature, greater amount of solid will be obtained as compared to high temperature. So cool down the solution. And then the filter, we will filter to remove salt crystals. And we can dry them. We can dry the salt crystals by tissue, or you can mention filter paper, because filter paper is having a capability to soak up the moisture. So when we obtain a salt from the solution, we can obtain by this technique. Is it clear? The first method to prepare a soluble salt or obtain a salt from the solution, the first, when acid react with metal. So when acid react with metal, it will give salt and hydrogen, but that salt will be a solution. So these are the points which you have to learn. Then the second method to prepare a soluble salt is the same technique. When acid is reacting with a base or insoluble base, which is also called a metal oxide. So acid plus base or insoluble base, because soluble base is known as alkali. Or you can also say metal oxide. So acid plus insoluble base, this will result in a formation of salt plus water. And this salt is not the solid salt, it will always be a solution. A salt solution will form, it will not be a solid salt, it will be a solution. Like salt will be dissolved salt. So what we do, how we carry out the same procedure is there, but this time instead of adding a metal, what we do, we add excess of metal oxide. So but the steps are the same. So example, if we have say nitric acid and it is mixed with insoluble base such as like calcium oxide. Metal oxides are also known as insoluble bases, which does not dissolve in water. So what will be the salt produced if it's a nitric acid, what will be the name of the salt? The calcium will take position of the hydrogen, so the salt will be calcium, because nitric acid gives nitrate salt, hydrochloric acid chloride salt, and sulfuric acid gives sulfate salt. So it will produce calcium nitrate plus water. So we want to prepare this salt. So how we can prepare? It's the same technique as we discussed. First we take a nitric acid. So first we take a nitric acid. So example, here we have nitric acid. And then we add insoluble base excess of a solid, like too much solid we add in the beginning. Like when we add this solid, the solid will start to react. But as we are adding excess of the solid, so a time will come when no more solid react and it will be left here. This is calcium oxide. And what we are left with is an unreacted calcium oxide. Because acid is completely used up, so some of the calcium oxide will be left unreacted. Then what we can do, we can use filtration to remove this metal oxide. So these are the steps. It's a similar step. That's why I copy from the last. Only few changes are there. When acid was reacting with metal, we were adding excess of the metal. But now acid is reacting with metal oxide. So what we do, we'll add excess of metal oxide. Then we'll remove the unreacted metal oxide by filtration. Then we'll use crystallization to obtain a salt from the solution and heat concentrate the solution till the crystallization point. We'll cool down the solution and then we'll filter to remove the salt crystals and dry the salt crystals by using a tissue or a filter paper. So same concept is there, same way we prepare the salt, but the only difference is the first one, when metal was reacting with acid, we use excess of the metal. But here because metal is reacting with metal oxide is reacting with acid, so we use excess of metal oxide. So metal oxide is solid. All acids are aqueous dissolved, and this salt which is formed is aqueous and water is a liquid state. So this is how we prepare a salt. If we want to prepare a salt, calcium nitrate, this is how it is done. So we have a nitric acid. As you can see, this is a nitric acid. When we add this metal oxide, calcium oxide, this nitric acid solution will turn into calcium nitrate solution. We don't see a solid form. The salt we don't see. The unreacted calcium oxide will be there. So this unreacted calcium oxide, how we remove that? The one which does not react, we can remove this by filtration. So once this unreacted calcium oxide is removed, like it is not there, then what happened? We are only left with calcium nitrate solution. And this calcium nitrate solution, we want to obtain a salt. We want to take out the salt from the solution. So if we want to take out the salt from the solution, what we can do, either we can use evaporation or crystallization. Like solution, we supply heat energy until all of the liquid escape and we are left with salt crystals. Or you can use crystallization, but normally in the lab we use crystallization rather than evaporation. And you will find the weightage, because if you write evaporation, you can only mention one point, like supply heat energy until all of the liquid escape and solid is left behind. So it's like only one point. But when you write about crystallization, you can write 3 points in general. So that is why it is appropriate you mention crystallization to prepare salt from the solution. Is it clear, the second method to prepare a salt? So all of the reactions of the acid can be used to prepare the salt. Then the third method is also same. When acid is reacting with metal carbonate. So acid plus metal carbonate, this will give salt, water, and carbon dioxide. So the states, when you check the state of acid, all the acids are aqueous, like the solution metal carbonate is solid, the salt will be aqueous, dissolved, the water will be liquid, and carbon dioxide will be gas. These are known as the state symbols, which shows what are the changes occur. Same thing happen. First we'll have an acid, like say sulfuric acid. So if you have a sulfuric acid, plus sodium carbonate. So when acid react with carbonate, what is the result? It will form salt. So which salt is formed here? It will, because sulfuric acid, so it will form sulfate salt. And the first name of the salt is always from the metal, so it will form sodium sulfate. That's right. Plus water plus carbon dioxide. So sodium sulfate plus water plus carbon dioxide, these are the products. So what happened in the beginning, we have again, like this is a sulfuric acid. Then the sodium carbonate is solid. So we add this sodium carbonate. This is sodium carbonate. When we add, the sodium carbonate will react and we use excess. Excess means like too much or more than enough for a complete reaction. So if we use too much sodium carbonate, it will react, and at the last some of the sodium carbonate will be left. So once sodium carbonate, because acid is used up, this originally it was sulfuric acid, but now it is not sulfuric acid, now it is sodium sulfate solution. So now it turned, because we use excess, now it is sodium sulfate solution, and this is unreacted sodium carbonate. So how we remove this unreacted sodium carbonate? We'll use filtration. So we use technique of filtration and we remove this unreacted sodium carbonate. So once this unreacted sodium carbonate is removed, now we are left with sodium sulfate solution. And how to obtain a salt from the solution? We can mention crystallization or evaporation. But in exam, try to write crystallization points as they are more in detail, and you can include more points if you're writing about crystallization rather than evaporation. So due to space, I just reduce the font size. So in this case, what we do, we add excess of metal carbonate, like too much metal carbonate. Then we'll remove the unreacted metal carbonate by filtration. Then we'll use crystallization until we obtain the crystals. So same points, as you can see, the three methods which we have discussed till now: acid react with metal, acid react with metal oxide or metal carbonate. We use excess of the solid, like too much solid, until all of the acid is used up, and we'll have a salt solution and the unreacted metal. The unreacted metal or metal carbonate or metal oxide is removed by filtration, and then after filtration we use a process of crystallization to obtain this salt from the solution. Is it clear, this technique? Any doubt to this point? That how we obtain a salt? From the three methods? Then the next method is acid plus metal hydroxide or base. That I will share another link and continue this.